revision of sums of chapter Refraction through lens. First of all the formulas. Lens formula 1 by V minus 1 by U is equal to 1 by F. What is the meaning of all these symbols? I'll tell you. And magnification is equal to I by O is equal to V by U, where U is equal to distance of object from the lens, that is from the optical center. All the distances are measured from optical center. V is equal to distance of image from the lens, again from the optical center. F stands for focal length of lens. M is equal to magnification. O is equal to size of object, and I is equal to size of image. Now the sign convention, if you remember x and y axis, right hand side of x axis is always positive. Correct? Do you remember? So anything on this side will be positive, anything on this side of the x axis will be negative, anything vertically up will be again positive, and anything vertically down is negative. So let us use this coordinate axis for our sign convention. This is the object, red colored, placed always on the left hand side, and it is denoted by symbol capital O, the size of the object. Hence the size of the object will be always, it is vertically upward. So size of object is always positive. Suppose if the real image is formed, so let me draw real image is always inverted. Correct? And the size of the image is denoted by the symbol capital I, and real image will be always the size minus because it is vertically downwards. Now let us talk about the distance. If I move from optical center towards the object, it is denoted by symbol U, the distance of the object from the lens, and we are going on the left hand side, so hence it will be always negative. Distance of the image from the lens is on the right hand side, so V will be positive. This is called as sign convention. While doing the numericals, we are going to use focal length of convex lens is over here. When we talk about focal length, it is always second focal length. It is on the right hand side. So focal length of convex lens is always positive because it is on the right hand side. If the image formed by convex lens is virtual, first of all the size of object vertically up positive. Now look at the size of the image also. It is also vertically upwards, hence I also will be positive. But what about U and V? U is always negative because it is on the left hand side. U and V both are on the left hand side, hence U is also negative, V is also negative. It is convex lens. F2 is always on the right hand side, so the focal length will be positive. This is the sign convention used for convex lens. Now the sign convention for concave lens. Concave lens, object again placed on the left hand side, so the size of the object is positive. Distance of the object from the lens, it is on the left hand side, so hence U will be negative. U is always negative in concave or convex. Now where is the image formed in case of concave lens? It is always formed on the left hand side. So the size of image which is vertically up will be positive. Correct? What about the distance of image from the lens on the left hand side? So V will be negative. As well as focal length also is somewhere here, F2. So focal length also is negative. So you can see U, V and focal length, all three things are negative in case of concave lens. Object is kept at a distance of 20 centimeters in front of it. Be very careful. Minus 20, left hand side. Image is also formed on the same side of the object. So that is on the left hand side. So V also will be minus. What is the nature of the image? Left hand side. Which image is formed by concave lens? Yes, it is diminished, upright, virtual. So image formed is virtual, erect and diminished. Second part, find the focal length. So by lens formula, substituting the values, be very careful about the sign. Now taking LCM. So the focal length is minus 20 centimeters. Why minus 20? Because concave lens ka focal length is on the left hand side. So that is minus 20. Third question, convex lens of focal length 25 centimeters. So convex lens it is. Focal length is on the right hand side. So it is plus 25 centimeters. Reading the question carefully. At what distance from the optical center the object should be placed? So U is how much? Such that you are obtaining a virtual image of twice the size of the object. Virtual image. Virtual image is found on the left hand side. Virtual images are upright. Let the size of the object O be equal to X. So I will be plus 2X. Therefore, I by O is equal to V by U. Hence, when I substitute the values, 2X upon X is equal to V by U. So I can also write it as V is equal to 2U. Now using lens formula and substituting the values, F is 25, but V, instead of V I can write it as 2U. So writing 2U minus 1 by U, taking LCM. So we get U as minus 12.5. What is the meaning of minus 12.5? That the object is placed in front of lens. 12.5 centimeters in front of the lens. Fourth question. Convex lens, focal length is given to you. Real image, size 3 times the size of object. Size of object, I'm assuming it as X. So image will be minus 3X. Inverted, downwards. Remember that. Using the formula of magnification, substituting the values, I get X gets cancelled. Hence, V is equal to minus 3U. Now using lens formula, substituting the values in this, and now taking the LCM. So the value of U, we get it as minus 0.16. Why minus? Because it is on the left hand side. Fifth question. Object lies at a distance of 1 meter from the screen. Screen means image, where the image is formed. So distance between object and image is 1 meter. So this distance is 100 centimeters. And convex lens it is, remember that, is used to form an image placed at a distance 75 centimeters from the lens. Repeating once again, a convex lens is used to form the image of an object on the screen placed at 75 centimeters from the lens. So if this red distance is 75, the red one, okay, centimeters, so automatically the blue distance will be 25 because total is 100. So this is your U, this is your V. V is plus, U is minus, remember that. And the question asked is find the focal length of the lens using lens formula. So focal length we get it as 75 by 4, and that is 18.75 centimeters. Second part, find the magnification. Magnification is V by U, substituting the value 75, but U is minus 25, remember that. So the answer is minus 3. Next question, if power of lens is plus 2 diopters, D stands for diopters, find the focal length. So let us solve it. Very simple formula. Power of lens is 100 upon focal length in centimeters. You can also write it in meters. Choice is yours. So 2 is equal to 100 upon F. Therefore, focal length is plus 50 centimeters. Plus 50 किसका focal length होता है? Do you remember? Convex lens. So if they ask you which lens it is, answer is convex lens. Next question, if focal length of concave lens is 20 centimeters, find its power. Same formula, power is equal to 1 upon focal length. It should be in meters. if you want to write it in using the same formula, 100 upon f, because f I am using in centimeters. But very careful, concave lens, focal length of concave lens is minus. So minus 20, hence answer is minus 5 diopters. Next we are going to solve the numericals of revision of the numericals of sound chapter. First of all, the formula is 9 standard formula, V is equal to F lambda, where V stands for speed. In this chapter it will be speed of sound. F is frequency, number of vibrations, number of waves in 1 second. Lambda is equal to wavelength. SI units hertz, SI units meter. Remember that speed is meters per second. Same formula can also be written as in terms of time period, but instead of that we can write time period is 1 upon f. That also can be used. 9 standard formula, speed is equal to distance upon time. So same formula. And some people have the habit of rectifying things. If you see in the question the word echo, reflection, sonar, radar, then use the formula V is equal to 2D by T. Directly you can use this formula 2D because the sound is going and hitting the object, coming back. So that is why 2D by T. Otherwise you can only use this formula V is equal to D by T if there is no echo. Remember that. So these are the only formulas. Let us start the numericals. First question. If the wavelength is 20 centimeters, always see to that you are writing everything in SI unit. So that is 0.2 meters. And wave velocity is given to you as 24 meters per second. They have asked you number of waves produced in 1 second. That is nothing but the definition of frequency. So V is equal to F lambda. So therefore F is equal to V by lambda. Substitute the value. 24 upon 0.2, that is 120 hertz. Or in short, how many waves in 1 second? 120 waves in 1 second. Second part, time in which one wave is produced. Indirectly they have asked you time period. Time period is 1 by F. So 1 upon 120, divide this, you will get it as 0.00833 recurring, which can also be written as, have a look, I'm shifting the decimal. Here is the decimal. 1, 2, 3 places I am shifting. Whenever you shift on the right hand side, okay, it is minus, degrees minus. So that many seconds. You can leave your answer this way also, but in exams, as I told you, we have objectives. You know, there will be 4 options given to you. So one of the option will be something like this. So that is why you should know the conversion now. Second question, calculate the minimum distance. Speed is given to you. Speed is given to you 350 meters per second. Sir, time नहीं दिया है क्वेश्चन में. Minimum distance के लिए time, my dearest everyone, definition 0.01 second. 0.01 or 01? 0.1. 0.1 seconds, not 0.01. It is 0.1 tenth of a second, 0.1 second. Now very simple. V is equal to 2D by T. Therefore, I can write it as D is equal to Vt by 2. So V is 350 into 0.1. Sorry. Yeah, upon 2. So 35 by 2. And that is 17.5 meters. A man standing 25 meters away, data distance 25 meters, produces sound. Calculate the time after which he receives the reflected sound. This time is asked. Speed of sound is given to you 350 meters per second. So V is equal to 2D by T. Okay. So they have asked you time. So time is equal to 2D upon V. Substitute the values. So time will be 2 multiplied by 25 upon V. V is how much? 350. So that is 50 upon 350. So time is 1 by 7, divide 1 by 7, that is 0.1428, which we can round it up as 0.143 seconds. And the next part they've asked you, will the man be able to hear a distinct echo? Yes, because minimum time needed for echo is 1/10 of a second, that is 0.1 seconds. Hence, he'll be able to hear the echo. A pendulum has a frequency of 5 vibrations per second. So 5 vibrations in 1 second. Now he hears the echo after 8 vibrations. So how much time it takes for 8 vibrations? Let's calculate that. 5 vibrations 1 second. So 8 vibrations in time t. So t will be 8 by 5. You can keep it as it is or you can divide 1.6 seconds. So indirectly time is given to you as 1.6 seconds. Find the distance. D is equal to Vt by 2. Substitute the values. So 2.8 and 8 into 34 is 272 meters is the answer. A person standing between two vertical cliffs hears 2 successive echoes at 4 seconds and 6 seconds. Calculate the distance between the cliffs. So let me draw. So the distance from the nearest cliff, time taken is the smaller one, that is 4 seconds. So let me calculate the distance x for that. First of all, distance is equal to, I'll use the same color. So d is equal to Vt by 2. V is 320 given to you. Time is 4 seconds and upon 2. That is 640 meters. So we got the value of x as 640. Now let us calculate the value of y. Same formula. D is equal to Vt by 2. Y is equal. So therefore y is equal to 960 meters. They have asked you to calculate the distance between the cliffs. So the answer will be 640 plus 960. So the distance between the cliffs is 1600 meters. A man fires a gun and he hears the echo after 5 seconds. He moves now 310 meters towards the hill and again fires. Since now he has reached more closer to the hill, now he hears the echo after 3 seconds. Calculate the speed of sound. So black one is the initial position and the red one after moving 310 meters towards the hill. So he moves. So this distance is 310 meters. And let us assume that the entire distance from this to this position, start to end position, is x. So how much will be this distance then? It will be x minus 310 meters. So now solving it. First the black part, that is from the initial position, v is equal to 2d by t. Distance is x and time taken is 5. So I have substituted v is equal to 2x upon 5. Now solving the second part, that is shown in red color. Same thing, v is equal to 2d by t. We don't know the value of v. Distance is x minus 310 and time is 3 seconds. Let us say this is our equation number 2. Equating both the equations. Cross multiplying. Solving this further. So x equals to 2 7s are 14. 775 meters. They have asked you calculate the speed of sound. V is equal to 2x upon 5. So 2 into 775 upon 5, that is 310 meters per second is the answer.